You are watching the Target 2.3 retest film. So in this one, we're going to take a look at some graphs and figure out some of the ideas that are behind the graphs. So some stories. We're going to take a look at some of the vocabulary words like maximum and minimums and rate of change as it pertains to some real life situations. So remember, you have to have your white packet out with you. I'll actually do some of the problems that are in it. You do have to have that done in order to do any retesting. And if you do need some work, some help in finishing that retest packet, you can see your teacher before or after school or during advisement. Your classroom teacher will always be available for you then. All right, let's take a look. We're actually going to do this, not do them, but I'm going to talk about these graphs a little bit. And if you notice, these graphs are depict three friends and their distances from Applebee's. They're planning on walking separately, but they're going to meet there in about 10 hours. So we're going to answer some questions based on them. So a good habit to get into when you're given a few graphs here is to kind of look at the graphs and figure out exactly what's on them and what the people are doing. Imagine what their story might be, that kind of stuff. So you need to know what's on each axis. So notice time in hours. So each one of these, each line marks an hour, all the way to 10 hours here. And then this is distance from Applebee's. Again, going from 0 to 10, each line is an hour or is a mile. This is Jerry's graph, this is Jesse's graph, and this is Tom's graph. And then we can notice some things about them. Now, one of the things that you see for sure, and this is something I noticed on the test, is that distance from Applebee's, when it gets down to 0, they're actually at Applebee's. So if you're in here trying to do this film to retest, that's probably something that you got wrong. So for example, Jerry gets to Applebee's right here. He actually gets there in hour 7. Another thing to think about is how fast are these people going, and are they going towards Applebee's or away from Applebee's? So this graph has 3 sections, this one, and this one. In that first section, he's not walking real fast, but in the second section, he is. He speeds up, and then gets to Applebee's, and it looks like right here in this third section that he's just hanging out. Okay, all towards Applebee's. He starts 8 miles away, gets there a few hours early. Whereas Jesse, he starts only 4 miles away, but notice this line is going up. That means that the numbers are getting bigger. That means his distance is getting bigger. He's going further away from Applebee's. And something happens here. He's not getting any further away, but then he walks straight there and is there at 10 hours. Okay, whereas Tom's a little weird. He starts 9 hours, he kind of just hangs out. Okay, but then he sprints because his line is almost straight down. He goes super duper fast. Maybe he catches a ride or something like that, and then is only 1 hour away, but never quite gets to Applebee's. He sits there 1 mile away that entire time. So those are good things to understand when you're looking at the questions then. Okay, go ahead and do questions 1 through 7 for that one. Let's go on to the next graph. The next graph shows oil production in millions of barrels per day. And then along the x-axis down here, these are years. So 1900 all the way to 2080. So some of that's in the future. Some things to notice. Notice that right away, we don't produce any oil, or very little. And then the graph increases all the way to this point right here, and that looks like it's a relative maximum. This is also a relative maximum here. It's bigger than the areas right around it. Then it starts decreasing all the way until 2080, but never gets exactly to 0. So a few things. I would like to do number 15 with you. So this one is a rate of change problem, and it says rate of change from 1960, that's right here, to 2020, that's right here. So 1960, it looks like it's matched with 20. That means in the year 1960, you have 20 millions of barrels of oil produced every day. In 2020, all the way up here, right there. That means in the year 2020, we will be producing about 60 million barrels of oil each day. So it's important to have those points. 1960 is the x coordinate, 20 is the y coordinate, and then 2020 is the x coordinate, and 60 is the y coordinate. So to find the average rate of change, we want to do the rise, which is the rise, that value, divided by the run, which is that value. So how far does it go up? It goes up from 20 to 60. That would be 40, and it's positive because it's going up. And the run goes from 1960 to 2020. That is positive 60 because it's going right. So when you divide those two numbers, you end up with 0.67. And now we need units. So units, the rise units had to do with millions of barrels per day. So I'll just say millions of barrels. Oops, it's just one L. Divided by the run, which is the years. So per year. Millions of barrels per year. That is your answer. So notice it was the rise, that's the Y's. So from 20 to 60 makes 40, and from 1960 to 2020 makes 60. That's the run. So these numbers, the Y's, go on top, whereas the run numbers, the X's, go on the bottom. All right, you'll get a chance to practice that in number 16 and also in the next graph too. So make sure that you practice it right. Check your answers on the back. All right, let's go to the next graph. This one has to do with John's savings account. So a couple things. Notice that it is getting larger as you go. I would like to do the domain and range for this one, and then you can figure out the domain and range for the other ones. Remember, domain has to do with x's. I think this is number 17, problem 17. And the range has to do with the y's. So in this case, real life situation, the x's go from 0 to 12. Notice there are points on either end. If there were arrows, we'd have to do something different, and I'll touch on that later in a different problem. So it goes from 0 to 12. That's the range, sorry, the domain. And we put the x in between, and we write it as a set of numbers from 0 to 12 in that case. So the range then goes from 300, that's the smallest value, to 1500, that's the largest value, and every value in between, and those are the y's. Okay, let's go to the next graph, and that's the people that have no insurance with respect to their age. So the age is down here, and these are the percent uninsured. That's written right there. Notice it stays about level here, but then a sharp increase right here to a relative maximum, and then it generally gets lower, and then a sharp decrease right here around 63 years, and then it stays the same over here. So what I would like to do is number 28 for you, which is another rate of change problem. And it says rate of change from 23 to 65. So 23 is about right at that maximum there, where it's about 35%. We're going to estimate that as 23 and 35. And it goes to 65, which is right here. So we're going to follow that up, and that's at about, I don't know, about 2, about 3. So we're going to estimate that as 65, comma 2, let's say. Okay, so rise has to do with these numbers, run has to do with those numbers. The rise in this case is actually going down. So we're going to make sure that that gets negative, and then the run is going positive. So down 33%, and it's going right, so that's positive, looks like 42%. When you divide that, and this is an estimate now, when you divide that, you end up with about negative 0.8%. That's on the Y column, and then the H, percent per year for the X column. So there's your rate of change there. So know some things, look at those. If you have any questions, rewind and listen to the tape again, but you should be able to see your teacher before or after school. On that, let's take a look at strictly domain and range problems now. I picked these 3 problems because they involve a few different parts here. This one has points on both ends. This one has a point, but an arrow on that end. This one has arrows on both ends, but notice it kind of like levels out. And we'll talk about that too. So the one with points on each end, remember domain has to do with the x's, range has to do with the y's, but it goes from, the x's go from -1 all the way to 5. So the smallest value is -1, and the largest value is 5. -1, 5. So we'll write it as a set of numbers like this, because it's everything in between. Whereas the range, the The smallest value is -2. Largest value is 5 also. That's these numbers. And it goes like that. Just write it as a set of numbers like that. And that's different from the ones with the arrows. So the ones with the arrows don't have the smallest value for x or for y. So we're just going to say the right hand side. So they don't have any number over here because there's an arrow. So we're just going to take that off. And this number is 2, 3, so the x's all are less than 2. And the range, the y's are all less than 3. So notice there's no numbers over here at all because there's an arrow there. The arrow says it goes forever. And the last one goes forever in both directions. This one is a little tricky because it never hits this y equals 2. We touched on it a little bit in class. We'll touch on it mostly in Unit 3 when we get there. But that's called an asymptote, and it never touches 2. So the range is all bigger than 2. It's all above 2. The domain, so it goes forever in this direction and ever in this direction. So the range is all real numbers. We can write it like this, or we can write it like this. And there you have it. So make sure you get in and ask questions. Check your answers on the back of the packet. Your teacher will be available before or after school or during advisement. Remember, you need to finish this in order to do any kind of retesting.